With problem number 7, again, we're looking for the highest exponent. We see a square right here. We see a linear term right here. So it seems like upon initial inspection, the highest exponent is in the numerator only. And our answer should work out to be that it does not exist, like was the case for problem number 5. But this is another trick. All right, we're taking the square root of x squared. And if we have the square root of x squared, that's leading us toward, that's leading us towards x. So we actually have an x in the numerator because of that square root, and we have an x in the denominator, which means that our highest exponent is in both. And therefore, our answer is going to be some kind of rational number like it was for number 1 or number 3. So what's our answer? Well, we're definitely going to use the 7. And up top, the second trick to this problem is it seems like we want to use the 4, but not quite. We actually want to use the square root of 4. So we have the square root of 4 over 7. That is our answer. And again, the reason being is because that x squared is under the radical, so this 4x squared under the radical is really behaving like 2x. And when you have 2x over 7x, that gives us our 2 over 7. Number 9 is a little tricky because we have this e to the opposite of x. Now you graphed e to the x when you were in pre-calculus. Okay, here's the graph of e to the x. But we're interested in e to the opposite of x. Well, when you negate the exponent, what ends up happening is you reciprocate the graph over the y-axis. This is the graph of y equals e to the opposite of x. And when x gets very, very large, over here, well, the value of the function gets really close to the x-axis. And the value of the x-axis is when y is equal to 0. So e to the opposite of, or e to the negative infinity, basically, when we're plugging in infinity, we're getting an answer of 0 in the numerator. In the denominator, we've got a billion, and we've got to add 1 to that. So we have 0 divided by a billion. 0 divided by a billion is 0. So when we have exponential functions, in one of the directions with exponential functions, and usually it's off to the left, but if in this case the exponent was negated, but in one of the directions, like right here, and like right here, the exponential function levels off, and we have ourselves some kind of asymptotic behavior. We have ourselves a limiting value for that section of the exponential function.